Okay, so let's just go over this one more time since we have the graph now with the A, B, C, D, and E on it. All right, so the first one was taking a look at which ones are biased estimators. So remember that bias means we're either consistently too high or consistently too low. So if we take a look at letter B and letter E, notice how almost all of the data is below the true mean. Over here, letter E, almost all of the data is below the true mean. So these two are biased estimators because they're consistently too low. The center of their sampling distribution, which is going to be here or here, appear to be below the correct value of 342. Okay, so we said that B and E were definitely biased. So which one is the best between A, C, and D? So when we're looking at A has a lot of values that are above it, but it has the least variability. So it only ranges from about 100 to a little bit over 400, where if we take a look at C and D, their means might be close to the true mean, but they do have a lot of sampling variability. Okay, so letter A is going to be the best since it has the least sampling variability, and the mean of this one is this about the same as the mean of the true population. Okay, so then the question is, which one is the best to use to estimate the true population number of German tanks? Okay, so let's take a look at this because this is a little bit tricky, and this isn't necessarily always the case. So let's take a look at letter B. So even though B is a biased estimator, if we notice, almost all of the underestimates are very, very close to the truth, okay? The true population mean of 342 tanks. Although it is biased, okay, it does give us a pretty good representation of how many, the mean number of German tanks that there were in World War II. Okay, C is unbiased, but it's really quite variable, and we can't necessarily say that a lot of them are close to that true mean. For example, in 120 of the simple random samples, B produced an estimate within 5 of the true value. So that means almost half of them produced a mean that was about the same as the true population mean. However, C, okay, if we take a look at C, it was only true in 79 of the 250 SRSs. So even though B is a biased estimator, it's consistently too low. It's consistently too low, but it's really close. Most of the values that are too low are really close to the true population mean. And it doesn't have very much variability. Most of them are right about here. Okay, so sometimes when you're given data, it is possible that a biased estimator is actually a better estimator of the true mean than an unbiased estimator. Okay, so unbiased estimators, just keep in mind, are not going to be perfect. All that unbiased means is it won't be consistently too high or too low. The center of the sampling distribution will be in the right spot. That's all that unbiased means. The center will be where it should be, but it doesn't necessarily mean it's the best estimate of what your population actually looks like. So you want to examine the graphs before you make a decision. Okay, so now when we assume that we have an unbiased estimator of the population, we also assume that the sampling process has no bias. So keep in mind, from our sampling distribution, we had to take many samples, find the mean and standard deviation of many samples, and then put those on the distribution and then find the mean of my sampling distribution. We have to assume that that sampling process we used to get those samples was a random sample, okay? We have to assume that the simple random sample wasn't a convenient sample or a voluntary response sample, because that is going to produce bias. Remember, with voluntary response samples, it's usually people that have strong opinions. Convenient sample, it's going to be, you know, easy for us to get, but not necessarily a great estimate. For example, even though X bar is an unbiased estimator of mu, okay, even though the sample mean is an unbiased estimator of the population mean, asking people in person how much they weigh will probably consistently produce estimates that are too small. All right, so in this case, it will be an unbiased estimator. Okay, so in this case, this should actually say bias. This is going to be a biased estimator because it's going to produce estimates that are too small. Okay. All right, so just a couple of things to sort of be aware of. Be careful with the distinction between the distribution of a sample and a sampling distribution. Make sure you're using those words correctly. So you will lose credit on the AP exam and free response questions if you misuse the statistical terms. If you call it the distribution, and when we're talking about distributions, you don't just want to say the distribution. Be specific. Are you talking about the population distribution, the sampling distribution, or the distribution of a sample? So the distribution of a sample and a sampling distribution are two very different things. So make sure you make that distinction. Okay, so take a look at this example. When we describe a distribution, make sure to state the distribution of the population of M&Ms or the sampling distribution of M&Ms. So when we take the population, that means I had all the single values of M&Ms, put them on a distribution. Sampling distribution means, hey, I took a bunch of samples and found the proportion of red in all the samples and then put all of those p hats on a distribution. For example, consider the statement, variability decreases when the sample size increases. Well, which one is that true for? Is that true for the population or the sampling distribution? It's true for the sampling distribution, but not for the distribution of one sample. Not for the distribution of one sample, and not really for the population either, okay? So when the sample size increases, because remember, the population distribution is not going to change. It is what it is, okay? So just be careful with your wording. And then in the next several sections, we're going to be looking specifically at sampling distributions of means and proportions. And if you want to take a minute and look at what these are, those are just what you should have learned in this section. So if you have any questions, please feel free to email.